Hey, welcome to this Programming for Cultural Heritage lecture. Today we're going to be talking about Git and GitHub. We're going to cover, kind of the basis about Git, what it is, why would you use it, and how to use it. And then we're going to really look at using Git and specifically GitHub today. So Git is a revision control system. So that sounds pretty complicated, but it's basically a way to keep track of files. And in this case, mostly these files are going to be the source code files. So in our case, this is the .py script files that we've been working on. And so it's important to kind of have a system to keep track of these because these things change over time, right? You edit your script, you add more stuff to it, you take stuff out, you change it, all these sorts of things happen to your source code. And so what's nice is to have a system that can kind of keep track of these changes as you go along and as things develop. So what's nice is you can actually, set up different versions, like kind of snapshots of this code. And then once you have those versions set up, you can always kind of revert back to those existing versions. So it's a way to kind of keep track of your changes and actually go back if you need to, if something bad happens and you want to recover to a previous version of it. It's also just nice to keep track of your history of changes as you develop. And also, nice thing about this is that it's collaborative. So it's not just that you're working on your own files, you can actually invite other folks to work on your same project as well. And so you can have other people contributing code to your projects, to your source code. And this can be just from you and another person to literally hundreds of other people contributing to the same project. So when you get to that level of collaboration, you need a system that should be able to kind of keep track of everything and make sure it all is in order. So this is kind of abstract, but if you kind of think of a visualization of this, there's a couple cool visualizations of tracking the history of a repository being developed. One of them is this Linux development kernel. And so this is basically the kernel is like the core central piece of an operating system. So in this case, it's the core of the Linux operating system. And these folks use this visualization library or tool GSource to visualize the commits to this repository. So each one of these little circles that people are working on is a file, right, in the repository that's being modified. And so you can see, there's really a lot of folks working on this repository and modifying it. And so Git allows you to have these very specific commands around doing certain things to a file and changing it. And Git works at the kind of line-based level of a file. So if you change one of the single lines in the file, it understands that line was changed, and it keeps track of that change to that specific line. And by combining those together, you can kind of really get very nuanced history and tracking of the changes in a specific file over a period of time. So of course, these folks are working on various files in a kernel operating system, which has many files, is very complicated, but they're managed to orchestrate this kind of development together using Git. And another example is that, as I mentioned, most of the time these things are going to be source code, right? But in this case, the Shelley Goodwin archive is using Git to manage their XML files. So these are the TEI, which is like a very verbose markup of textual documents. And so they use Git to manage their TE files. And so they can use it to kind of keep track of changes over time and make sure things are very ordered, and things that are added to the archive and changed have a very kind of robust history and change log associated with them. So it's a way to not only modify and keep track of source code, but to also do other types of files. And so, for example, cultural heritage, in this case, XML files. So there are other versions of this idea of revision control for source code in other files. Older ones are like Subversion, which works a little bit differently than Git. And there's also one called Mercurial, which is also works a little bit differently from Git. So we're going to talk about Git, though, is because Git is the most popular revision control system by far today. And if you use Git on a project, most folks know how to use it, and it's kind of a very kind of default system to go to when you start working on a project. So the workflow that we're going to be working with Git, and again, Git is it's kind of very abstract. So basically, it's a program on your computer, and so Git is a little program on your computer that basically makes a little database in a directory on your computer and starts controlling and keeping track of all the files in that directory once you add them to its kind of awareness, or you check them into its awareness. So this is just software running on your computer, and it basically makes like a little database for a specific directory and all of its contents. And then it keeps track of all that history as you change those files and as you go along. So basically, will be a program that you'll install on your computer, and in your terminal, you'll be able to use these Git commands to do various actions to modify and change what's actually in your Git repository for that project. So there's basically a few different commands. There's tons and tons of Git commands that are very elaborate and lets you do anything you want to do in Git. But one of the major ones that we will cover today are just basically initializing a project, cloning a project, so pulling a project down from somewhere, a remote repository, adding something to the repository, so committing a file to the repository, and then pushing it up to the remote repository like GitHub, and then pulling down files or pulling down changes from a remote repository. So git clone, git commit, git add, git push, and git pull are basically the main commands we're going to be using today. So this is kind of a might be useful diagram for you to understand the workflow for a Git work process or adding files to a Git repository. So you have this kind of different stages of this repository in a kind of a conceptual space. So you have your workspace, and you have your local repository. And so this is basically, you can have a Git repository in your computer, right, on your computer. And these are just basically files that have changed on your computer, and it's tracking the changes of them on your computer. So that's really useful because you can revert back to previous versions on your computer. But what's super useful is then you can then push them up to a remote repository on the internet. And so in our case, the remote repository for us is going to be GitHub. And so you can consider that a remote repository. And so basically you're going to add files to your local repository, commit them, and push them up to the remote repository. And then if there was changes made to them by somebody else, you could pull those changes back down to your local repository. So you think about this as like a little local database that you're making changes to, and then you're pushing them up to a remote database that can then be pulled back later, or other folks can modify, and then you can pull their changes down. So as I mentioned, the remote repository that we're going to be using is GitHub. But there are other providers of these remote repositories, right? And so Bitbucket is one of them that's run by Atlassian. And you can actually even run your own kind of remote repository. And this comes in the form of GitLab. So if you're a large organization and you don't want to use GitHub, you want to use your own, kind of have more control over everything, you can run your own GitLab instance, and you would have your own remote repository for folks in your organization to check in code to. But one nice thing about GitHub is that it ties in these kind of account features and social features. So you can also, have things like permissions and stuff like that built into your who can actually contribute to a repository and stuff like that. So to get started, you need to have Git on your computer. So you might already have it, but if you don't, or you're not sure, you can head over to, for Mac users, you can head over to desktop.github.com and download their tool, which is this desktop app. So this actually installs like a GUI, like a graphical interface, but it also installs a command line one. And we're just going to be looking at the command line tool because it's a little bit more powerful, and it's good to get some experience with that. So if you install this for Mac, it will install the command line version of it as well. For Windows folks, let's go through the process of installing it now. So if you're on a Mac, you can skip ahead a few moments here while we get started on Windows. So we're going to install this Windows Git for Windows tool suite for our Windows folks. So we're just going to run this and install it. And we'll see how we do installing this here. And this basically installs a series of like very Linux-based kind of command line tools for you, including Git. So you can use it from a terminal kind of application the same way you'd use it on the Mac or Linux. So we're going to install this. Yes, yes, yes. I'm going to add a desktop icon. I'm going to use TrueType fonts in my Windows, console windows. I'm going to say OK. Now this is going to say which editor do you want to use. And so by default, it's using the Vim editor, which is very hard to use. So we're going to pick something else. We're going to use, let's use Visual Studio Code as our default editor. Let's see, adjust the name initial branch. Yeah, so if you don't want to call, so the way Git historically has called branches, which are kind of components of the repository, are master and is as the main one, but of course you can override that now and say something like call it main, which is a much better option. All right, so Git from the command line and Git also from third-party software. That's fine. That's fine. Check out Windows style. Yes, that's fine. Okay. Lots of options. Okay. Let's see if this works. Okay, so it's finished installing. So now we will have a Git bash icon on our desktop if we select the desktop icon. And so if you run that, it basically opens a terminal. And this terminal has all the same commands as a Linux kind of machine. And one of those commands is Git. So if you type Git, it should actually run a Git command. All right, so if you got to that point, then you know you've installed Git and you can start working with it as well. All right, so the next step is we want to think about the workflow that we're going to use. And so the easiest way, if you want to start using GitHub and make sure your files are on GitHub, is to start working by creating a repo on GitHub, the GitHub site, and then cloning that to your local computer. And so by doing that, you can basically make sure that you're establishing the remote repository and it's ready to go. And then you just clone it to your wherever you want to work on it locally in your desktop or on your computer somewhere. And then you can start, you know, it's actually there and it's ready to go. So let's do an example of that. So I'm going to go to GitHub. And so there's a lot of ways of doing this, right? And this is just one way, but it's kind of like the quickest way of getting started. So I'm going to go to, I'm in GitHub, and I'm going to go to create a new repository here, this new button. And it's going to call it something like, you might be working on your final project, so you might want to call this like PFCH final project or something like that. I'm going to call mine PFCH 2020. You could add a description, and so this is just a little text about your project. So public and private, right? So if it is a public repository, anybody on the internet can see it. If it's a private repository, only you can see it and folks that you invite to be your collaborators. It doesn't really affect how you can interact with it as far as pushing and pulling and stuff like that. It's just basically no one else can see it or even knows it exists if you select private. And you'd have to check the current account things or account limits, but I think there are some, you're allowed to have some private repos on GitHub with a free account. So a README file is basically just a file called readme.md, and the MD stands for Markdown that goes into the root of the project, and it basically is just a little about page telling folks about the project. A git ignore file is a file that is added to the project that basically tells the Git repository to ignore certain files. So imagine if you're working on a project that uses a huge CSV file that's like, 200 gigabytes or something like that, right? You're not going to be able to put that into your Git repository, and you probably don't want to, right? And so what you can do is you can make sure that you have a git ignore file, and it starts with a period here, period git ignore, one word, and that's the name of the file that's in the repository, so it's in the same directory as your files. And you basically go in there and tell it what files you want to ignore. And so you could say, okay, ignore huge file.csv, right? And it will not try to keep track of that file, and it'll just completely ignore it. So you want to probably add an ignore file in there. Another use case could be, say you want to have some password files in there, right? So you don't want to put your password files, like your API keys or something like that, up into the cloud, up into GitHub, and allow people to see it. So you could actually have your passwords or your API key stored in a file, and then git ignore that file, so it's never pushed up to GitHub. And they provide some kind of pre-made ignore files, so you could actually add the Python pre-made git ignore, and this just ignores some typical kind of like detritus files that Python generates, and it ignores it. Then, of course, choosing a license is always important. You can pick a license that you want to distribute your stuff under. It's nice to add a license because then folks are sure that they can use it or not, and there's no ambiguity about, is this really open source? Is this free, etc. All right, so I'm going to curate the repository. And again, this workflow is like you're starting with GitHub first, and you could totally go the other way where you can start locally and then push up to GitHub. But we're starting with GitHub first and then pulling down locally. And so basically here is it creates the repo, right? And it has the three files. There's the git ignore file, the license file, and the README. And this is a markdown rendering of the README file. And then if you want to clone it locally, you basically need an address to clone from. And so the clone URL is here. And so basically this URL is the address to your repo, your Git repo, and you need that to clone locally. So I'm going to press this and copy it to my clipboard. All right, so now I create a repo, a remote repo on GitHub. And so the next thing I'm going to do is go over to my terminal, and I'm going to clone it. And basically cloning means you can basically copy a repository from a remote repository locally, right? You're cloning the repository exactly. So I'm in my downloads directory, so I'm just going to say git clone, and then I'm going to paste that URL that I just copied from GitHub. And so it's going to say cloning into PFCH 2020, and it's going to do that. And if I did this in my downloads, so I can now change directory into PFCH 2020. I actually created a directory in my downloads, which is this repository. And now that I'm in the directory, I can see that it has these two files here, right? The license and the README. And you might say, like, well, where's the git ignore file? And so on Mac and Linux computers, the files that start with a period are hidden. And so if you type ls-a, stands for all, so list human, and then in all four files. And then you could see here's the current directory, the parent directory, here's the git repo, and then here's the git ignore file, right? And if you actually went into this directory, the git is a directory, you can see all the files that make up the git repo, right? And so this is a magic. This is just a little tiny file-based database that keeps track of everything in here. So these are all the git repo files that basically keep track of your project. But that's hidden by default, right? So you don't really see it. All you see are your files that you're working with. So here are the two like real files, right? The license and the README. That's all that's in there so far. So let's try to do this on Windows also. Let's give it a shot and see if it asks us to kind of validate ourselves or authenticate ourselves. All right, so I'm going to see where I am in here. I'm in Git Bash, so I'm in IE users, so that's where I am. So I'm going to change directory to my desktop. So now I'm on my desktop, and there's not much on my desktop. And so now I'm going to try to git clone, and the problem is I I have to get the URL to that repo. So I'll do that really quickly. Or I could change into that directory. And there are my files there. All right, so that's how you clone something. And once you have this clone repo in your directory, it's now kind of tracked, right? It's this little database that's living on your computer. That's your local version of it that you can do stuff with, right? Add new files to it. And so basically probably what we're going to be doing, right, is creating new files, editing files, and then committing files and pushing them up to GitHub. So if we were going to create a new file, right? So let's say we're in Sublime. I'm going to create a new file here. So I'm going to create a new file called, I'll call it tests, right? Test.py. And I'm going to save it in that pfch directory that we just cloned into. And so I'm going to save it to there and hit save. All right, so this is a, just, it's a py file. I'm going to just say print hello. I'm going to save it. So now if I go to my, back to my terminal, I can see that this file is there, right? There's this test py that I just created. And so just by adding that file to that directory, Git is now aware that there's this file in the directory that it doesn't know about. And so one of the commands you can say is say git status. And it says, okay, I see there's like this new file that I don't know about yet. It's not in my database, but I see it's in this directory. And it says untracked files. And it says add, say git add and the file to include what will be committed. So the idea is that you make changes, you add the things that you want to bundle into a commit, and then you commit those changes to your local repository. So it's kind of thinking of it as this, like your directory is like the staging ground, right? You're making changes to a bunch of files, then you're adding all those files into this kind of bundle, and then you're committing that bundle into your history of changes, right? So say I do want to add this test py to my repository. I can say git add, and then the file name. And then if I say git status, it will say new file, this was added. And so now if I go back and change it, so I'm going to go back and change the, just change something in the file to say, hello again or something like that, right? Save it. So if I look at it again in my console, I say git status again, it will say, oh, you know what? I see that this file is there. I know about it, but now I see that you have modified it. So if you actually want to keep those changes that you just made, because Git's saying when I added this file, I added that version of the file, and now that I see it's changed, you need to add it again if you want to make that part of this commit. So then I need to add it again, right? And so now if I git status, git status, it says, okay, new file, everything's fine. So now that I have that created, I can, the next step is that all these things are being kind of aggregated in this commit bundle. And so the next thing I need to do is actually commit it to the history of the repository. So I say git commit, and then I have to give it a message. So I say -m, and I'll say added new test file. And it says, okay, I committed that file to this commit, and it's now in my history of changes. And if I say git status, it'll say nothing to commit, working directory clean, right? So that means that it's a clean directory. There's no changes need to be done. Everything is fine. And so the final step you can do is actually git push. And so if we went back to the web, we could see that on our page, these are the only 3 files that are here. And so once we go to our terminal and we simply say git push, it will know you're talking about the remote repository, and it will try to push these changes up to the remote repository. So now if we went back to the website, the GitHub website, and refreshed, we'd see, oh, there's our new test file that was changed 1 minute ago, right? And so this is basically the workflow that you do. You make changes in the directory, everything has to be in that directory, and then you make changes and you commit them, and then you push them up to the remote repository, in this case GitHub. So let's see what that looks like on our Windows, right? So if we go to our Windows, we've been making changes on our Mac side, and we push them up to GitHub. So those changes don't exist here on our Windows side, right? It's just the license and README still. So what we can do on our Windows side here is say git pull, and it will ask the remote repository, hey, are there any changes since I last checked? And it'll say, yeah, here's the change. And it will download the change. And now if I look at my directory, I'll see that test file. And so now say I added a new file, or I modify this file. Let's try to modify this file. So I clone this in my desktop. There it is. There's a PFCH 2020 repo name, and then here's the test file that I just pulled. So I could add another print statement here. Windows, right? And if I save that, let's save that here. And I went back to my terminal and I'd say git status. It would say, oh, I see you made a change to that file, the test file. And I would say, okay, yeah. So I'm going to say, I could say git add and then the file name. And then another shortcut is git add period. And period means everything in this directory. And so you have to be a little careful when you're using it, right? Because if there are things in the directory you don't want to add, then you wouldn't want to add it to, do git add period. But I know everything in this directory is something I want in the repo, so I'll say git add period. And that basically just looks through all the files in that directory and adds the ones that have changed or needed to be added. So I'll say git add period. And that will just go through and add all the files in that directory that have been changed. All right, so now that it's added to the repo, I'm just going to do git push and to try to push to the GitHub remote repository. And it will probably want to ask us to authenticate ourselves somehow. All right, so it's saying sign in GitHub. So I'm going to sign in to GitHub. And authorize it. Right. So now if I go back to the terminal, it authorizes it, and now I can, since I'm authorized now, I can push and pull from GitHub in this account. Right. So if I went back to the Mac side here, right, and I did a git pull, I would see that this had been updated, right, with those changes I made in Windows. So, if you go into the repo, you can always see the history of these changes, right? How many commits were done and what happened on each commit, right? So for this commit, I could see that this line was added, right? So that's basically the workflow of kind of going back and forth and changing stuff, modifying things, pushing, pulling, and committing. So there's some other features. One of them is that you probably won't need to use, but if you're working with like a team or an organization, you can do branches. So branches are basically up here. You see we have the main branch, but you could actually have additional branches. So for example, say you were working on a website and somebody's responsibility was to build the header, right? And so that could happen independently of the rest of the project. So someone might make a new branch and then work on that header, and then eventually pull that branch back into the main branch. And so it allows folks to kind of work on stuff parallel without interfering with each other. And so while Git is very good for line-based changes, you really don't want to be working on the same file as somebody else at the same time, because then you'll start getting to these what are called merge conflicts. So the Git software will try to take your changes and the other person's changes and mush them together, and things that are changed on the same line will have lots of problems. So it's better to try to avoid that and just to kind of work on independent files at a time, and different features like that. So if you are if you wanted to make a new branch in your terminal, you could do that. So you can say git checkout and then B, and then we'll say new branch. Oops. Say new underscore branch. And so now if I say git branch, it'll show you what branch I'm on. So if I made a new file here, if I say I made a new file by copying the test to test2.py. So now there's two files. Then I git status. There's that second new file there. I can git add it and git commit. Git push. So it says the current branch has no upstream branch. To push the current branch and set the remote as upstream, use git push upstream or origin new branch. So this is basically the remote repository saying I don't have that branch yet, so you can't push it to me. And so this is just saying create it. All right, so now the new branch is created, and if you went back to GitHub, you could see that if you refreshed that there is now a new branch. And so that second file test2.py doesn't exist on this main branch, but if I switch to the other branch, the new branch, it would exist. And so what you can eventually do is issue a pull request. And so basically a pull request is a request to merge a branch into the main branch and kind of resolve all the conflicts and bring them together into one branch, the main branch. And so doing that, you kind of gives a chance for like code review, right? If folks want to review the changes and approve them, and then they can pull them into the main branch. And it's a great way to work on separate features. Similarly is this idea of forks. And so GitHub, this one exists on GitHub. This is like a GitHub feature where you're able to basically take someone's repository and fork it into your own repository. And so this is nice because it allows you to basically copy someone's repo and not have to rely on them to make changes, right? So let's see, what was it called? Yeah, so for example, I made this Omeka Zoom or Omeka plugin a long time ago. You can see there's 7 forks of it, right? And so if you looked at these forks, each one of these people, each one of these organizations, or each one of these users, GitHub users, had forked it at some point. And actually, this person had forked it from me, and then someone else forked it from them, and then someone else forked it from that person. And so you can see that forking allows for kind of a repository to keep going under someone else's ownership, and it be their own version of it, right? So you can see I stopped working on this way back in whatever year this was, 2015 or something, right? But this person kept working on it, and it's has worked on it for a long time since. And so it allows for a way for someone to kind of take your code and keep running with it, and not have to interact with you to get code back into your repository. And so at some point you could pull this fork back into your repository and kind of merge them together to be updated. But at this point, this is so far ahead that this is a completely different, basically, project at this point. So branches and forks are very useful in their own ways. And also, of course, a nice thing you can do with Git is if you make a mistake, you can actually do Git checkout origin and then the file name. And so if I made a mistake and I wanted to revert back to the file of a version of the file that's up on the remote repository, so up on GitHub, you can actually pull that file back down locally, and it would replace your local file with what you had last pushed up to the remote repository. So it's a nice kind of like fail-safe. If you completely break something and you don't really want to figure out how to fix it, you could just pull back the last version of it that you had in the repository that was a good version of it. So this is branches works. So here's some more information about Git and GitHub. And so there's a little tutorial if you want to go through some more options and play around with it. And then also here's kind of like a cheat sheet. There's a huge amount of Git and commands that you can use to master. So Git is really kind of complicated, and it can be very kind of, I'm always looking up how to do something, but it is a really powerful tool. And if you keep in mind that these very simple, straightforward commands like git clone, git add, git commit, git push, git pull, those are really like the 5 things you need to know to get started working with Git and, even collaborating with other folks. So thanks for watching, and I will talk to you later. Bye.